This is section 4.2, part B, degrees and radians. Arc length is the length on a circle that is defined by a specific angle. So this would be an arc length. So it's the part of a circle or the circumference of a circle for only part of the entire circle. To find the arc length, you're going to take your central angle, and it needs to be written in radians, and you're going to multiply it by the radius of your circle. So find the length of the intercepted arc in a circle with a given central angle measure and radius. Round to the nearest tenth. Now we do know our angle measure currently in radians, so the arc length is r times theta. Our radius is 5 centimeters. Our angle is pi over 4 radians. And if we multiply those two together, we're going to get 5 pi over 4 centimeters, or your arc length is approximately 3.9 centimeters. Now for this example, we're in degrees instead of radians. So the first thing we need to do is convert this degree measure to radians. Remember, since degree is on top, we're also going to put degree on bottom for the second one, and we'll put our pi radians on top. 60 goes into itself once, 60 goes into 180 3 times, so this will give us pi over 3 radians. Now that we know this angle measure in radians, we can find the arc length. We know the radius is 2 inches, and we know our angle is pi over 3. So our measure is going to be 2 pi over 3 inches, or approximately 2.1 inches. So again, this is just telling you if you have your circle and we know we have an arc, or we have an angle that is pi over 3 radians, that's just telling us the length of just that portion of the circle. Linear speed is the rate at which an object moves along a circular path. Linear speed is measured in units like miles per hour. So it's how fast that you're going around a circle. Our formula for linear speed is v is equal to s over t, where s is the arc length and t is time. Now another way we can write this, we know that s is equal to r times theta, so we can also write our linear speed is r times theta over t. Angular speed is the rate at which the object rotates about a fixed point. So angular speed is measured in units like revolutions per minute. So how many times can the bicycle wheel go around in 1 minute? Our formula for that is omega is equal to theta over time, where theta is your angle in radians and t is whatever time unit you are using. A bicycle messenger rides the bicycle that is shown. During one delivery, the tire rotates at a rate of 140 revolutions per minute. This is the angular speed that we need to find. So we know that it's 140 revolutions in every 1 minute, but we need to know how many degrees that is. So 1 revolution is equal to 2 pi. So if we do 140 revolutions, we can multiply this by 2 pi, and that'll tell you how many radians we have covered. So our theta is going to be 280 pi radians, or our omega will be 280 pi radians over 1 minute, or the omega is just 280 pi radians per minute. One part of the trip to the next delivery, the tire turns at a constant rate of 2.5 revolutions per second. Find the linear speed of the tire in miles per hour. Now, if we look at the tire, we know that the diameter of the tire is 30, so we can see that the radius would be 15 inches. So we know R is equal to 15 inches. Now to find our theta, if we're doing 2.5 revolutions and each turn around the wheel is 2 pi, then we know that theta is going to equal 5 pi. To find the linear speed, we use the formula V is equal to S over T, or we know the arc length is R times theta, and we can put that over T. So to find our linear speed, we're going to do our radius of 15 inches times our angle of 5 pi radians all over 1 second, because the problem tells us this is how many revolutions it's making per second. So we know our linear speed is going to equal 75 pi inches per second. If we write that in miles per hour, we're going to have to convert these units. So we have 75 pi inches every 1 second, and we need to convert this to miles per hour. So we know that there are 12 inches in every 1 foot, and we know there's 5,280 feet in every 1 mile. Since seconds is on bottom, we know seconds are going to go on top, and we know there's 60 seconds in 1 minute. And because minutes is on bottom, we know minutes have to go on top. There are 60 minutes in every 1 hour. Now let's cancel our units to make sure everything is going to be left with what we want. So our inches cancel, feet is on top, feet is on bottom, so that cancels. We're left with miles on top, which is what we wanted. We have seconds on bottom, seconds on top, those cancel. Minute and minute will cancel. We're left with hour on bottom. So if you multiply straight across the top, straight across the bottom, and then divide the two numbers, you're going to be left with 13.4 miles per hour. A sector in a circle is a region bound by a central angle and the intercepted arc. You can think of a sector as a piece of pie. It's going to be the whole area, not just the outer part, but all of the stuff inside the circle as well. So to find the area of your sector, you're going to use the formula of 1/2 times the radius squared times theta, where again, theta is measured in radians. So we need to find the area of this sector. Our formula is 1/2 r squared times theta. Our angle is given in radians, so that's good. We know our radius is 3. Our theta is 7 pi over 8. And if you plug that into your calculator, you should get 12.4 centimeters squared. This is area, so your units will be squared. Find the approximate area swept by the wiper blade shown. If the total length of the wiper blade is 26 inches. So if we needed to find this whole section here, everything inside the green of that sector, we would do 1/2 your radius squared times your theta. We know that the entire wiper blade itself is 26 inches, but first we need to find this angle in radians. So currently we have 130 degrees. Remember, we're going to multiply that by pi over 180. Now 10 goes into both of these. 10 goes into 130 13 times, and it goes into 180 18 times. So this is equivalent to 13 pi over 18. So we plug that in as our radian measure. And that tells us the whole green area would have an area of 766.9 inches squared. but we actually only care about the part that the wiper is cleaning, which would be this part right here. So if the whole mechanical arm is 26 inches and the wiper itself is 16, then that means we're left with 10 inches down here that's not actually being cleaned. So if we find the area of that 10-inch part, we're going to do 10 squared times, our angle is still the same, so that's still that 13 pi over 18. And that's going to give us an area of 113.4 inches squared. So inside the whole green region, we have 766.9, but we're not going to use the stuff inside the purple. So to find just the red, we can find that area by taking the whole piece and subtracting out the piece that actually doesn't get cleaned. And that's going to leave you with 653.5 inches squared that actually gets cleaned on your windshield.